Hello everyone, welcome back to Math Online. I'm Mr. Solis, and on today's video, we're going to go over the Chapter 3 practice test. On this video, we're going to go over concepts on how to find the common difference, how to evaluate a function, how to use the slope formula to find the slope given 2 points, how to find the slope using rise over run when given a graph, and how to graph a linear equation. All right, class, let's move on to the next slide. So on this scenario, they're asking us to find the common difference and the 3 terms in the sequence after the last one given. Just to recall some information, the sequence that is given to us is an arithmetic sequence. What does that mean? It means that this sequence will have a common difference, or in other words, a pattern of either adding by a number every single time or subtracting by a number every single time. Okay, it's a fixed number, in other words. So here we go. First thing we're going to do is to find the common difference. So in blue, I'm going to say, all right, we're going to do the first step, I guess. Find the common difference. We actually use the lowercase letter d to represent the common difference, which stands for the pattern, right? So try to think about what the pattern will be just by looking at these numbers. As you can see, some of you guys might know what the pattern is just by looking at the numbers, but sometimes it won't be that easy to identify the pattern, to realize what the pattern is. So we actually use a short and small formula to calculate the common difference, to calculate the pattern. All right, so this is how you find the common difference. What you need to do, or first of all, what you need to understand is that every term on the sequence, every number on the sequence is a term. So 21 is the first term of the sequence. The second term would be 19. The third term would be 17. And the fourth term would be 15, and so on and so forth, right? So in order to know what the next number on the sequence will be, and the next number of the sequence will be, and the next number, we need to identify what the pattern is, okay? So let's go ahead and do that by using this formula. Like I said, some of you guys might already know what the pattern is, which is awesome. But if you don't, here's how you find them. Okay? Here's how you find the common difference. You'll take the second term of the sequence, and you'll subtract it from the first term. So in other words, take the second number of the sequence minus the first number of the sequence, and that's how you'll calculate or find the common difference. So let's go ahead and do that. We're going to say D, which stands for pattern or common difference. We know that the second term of the sequence is 19 minus the first term of the sequence, and the first term of the sequence is 21. So when we simplify this, 19 minus 21 will give us that the pattern or the common difference is -2. Now this pattern or this common difference is super important because this tells you how to find the next numbers on the sequence, which is the next question that we were asked. So in red, we were asked to find the next 3 terms of the sequence, right? So what we got to do is notice the pattern if it works. So we know that the pattern is -2. That's what we came up with. So let's see if it works. 21 minus 2, does it give us 19? Yes. 19 minus 2, 17. Great. 17 minus 2, 15. Awesome. We're doing good so far. So we will continue the pattern to find the next 3 terms. So 15 minus 2 is 13. Good. 13 minus 2 is 11. Awesome. And 11 minus 2 is 9. Good job, class. Awesome. Hopefully this helped you to find the common difference of an arithmetic sequence and be able to find the next 3 terms of the sequence. Okay. So here we go then. We'll move on to the next slide. All right, class. So on this next example, on this next problem, we need to evaluate the function. So first of all, we need to understand what is the function and what is our x value. So first of all, in blue, I'm going to circle the function itself. So this is the function that we need to evaluate. And this is the x value that they ask us to plug in into this function, right? So what we're going to do is we're going to substitute -8 for x. That's what we're going to do. That's how you evaluate a function. So in this case, we're going to say, I'm going to actually rewrite the function just as a reference. My function is f of x equals x plus 5. So the whole goal here is to substitute -8 for x. So in other words, you're replacing the x for the -8. Again, we're going to say instead of saying f of x, we're going to say f of -8 equals, and then we'll plug it in again, -8 plus 5. And when we simplify this, we'll get f of -8 stays the same. Notice how the left side stays the same. You're pretty much simplifying the right side, the expression itself. So -8 plus 5 in a perfect world will give us -3. So this would be your answer. F of -8 is equal to -3. Now, what does this mean though? If I was to ask you, what does f of -8 equal to -3 mean? All it means is the following. You could write a statement that goes like this. When x equals, and x was given to you, x is -8, so you're going to write x is equal to -8. When x equals -8, f of x equals -3. That's the number that we simplified. So that's f of x equals -3. Okay. So to put it in another perspective so that you guys have a better idea, it's kind of like an order pair, right? Pretty much an order pair. You were given an x value, right? Remember, an order pair has an x and a y value. In this case, they gave you the x value and they're asking you to find the y value, in other words. But instead of using a y on the order pair or on the function itself, they're using function notation, and instead of the y, they're using f of x. So the x stays on the same spot, but instead of a y, we have f of x. So that's now you can have an idea of where I got the f of x. So if this wasn't function notation, instead of f of x, we would actually have y, because f of x is another name for y. Okay, so hopefully that made sense for you guys. So you could either write this statement or this sentence. Either one is perfectly fine. If you guys have any questions, please let me know. You can leave a comments below. So other than that, let's move on to the next slide. All right, so in this scenario, we need to find the slope of the line through each pair of points. All right, so in order to find the slope given 2 points, we must use a formula. This formula is called the slope formula. And the reason we want to use the slope formula is because we were not given a graph. Anytime you are provided with the graph, then you could easily use rise over run to find the slope. But in this case, they just gave us 2 points. Therefore, we will use the slope formula. Okay, so here we go. M is equal to y2 minus y1 over x2 minus x1. And pretty much what the formula says is just the difference between the y values over the difference between the x values of these given points. Okay, the change in y over the change in x. So now keep in mind that you can also graph these 2 points on a paper or on Desmos.com and use rise over run to find the slope. That's a possibility. But if maybe on a test or a quiz or a homework assignment you're asked to use the slope formula, then this is how you do it. Okay, I'll show you how to do that in a second. So first of all, this is the formula that we're going to be using, y2 minus y1 over x2 minus x1. Well, we're going to have to plug in 4 different numbers. Okay, now you were given 2 points. Now keep in mind that in every order pair, there's an x value, a y value, and once again, we'll repeat the process. This is an x value and a y value. But we don't want to have clones, right? We would have 2 x's and 2 y's. So what we want to do is distinguish those, right? So what we're going to do is we're going to label these with a specific notation, okay? We're going to call this, if this is the first point and this is the second point, we're going to call this the first point as x1 and y1. And this will be called x2 and y2. Okay? Now, keep in mind, this could have been the first points or that could have been the second points. It doesn't really matter what you choose to come first, but the labeling does matter. The labeling is important because if you mess it up, if you mess up the labeling, you're going to get a different answer. Okay? So make sure that when you label them correctly. If this point becomes your first point, it must have all ones. X must have a 1, Y must have a 1. If this is your second point, the X must have a 2, the Y must have a 2. Okay? And if you switch these points, then vice versa. Okay? All right. So with that in mind, let's go ahead and substitute these values into that formula. So let's go ahead and rewrite the formula over here. M is equal to y2 minus y1 over x2 minus x1. And let's go ahead and plug these values in there. So let's substitute our y values here. So we know that y2 is 10 because that's what we label it as. So as you can see, there's only one y2. This is not a y2, that's not a y2, that's not a y2. This is the y2, and it corresponds to the number 10. So I'm going to write 10 in there. And then the formula says minus, so I put a minus sign. And then I move on to labeling, writing down the number that corresponds to y1. And as you can see, y1 corresponds to 19. And then we put our fraction symbol here over, and then we'll write down the values that correspond to the x values, okay? So x2 in this case is -7, minus, that's what the formula says, the x1 value, which in this case is 20. And now we just got to simplify this out, either using a calculator or in our heads. Doesn't matter how you do it, to be honest. I don't mind if you use a calculator at this point. And there is a calculator, and I'll show you guys in a second that you guys can use, in Desmos, of course. All right, guys, so here we go. I'm going to take you guys to the website where the calculator is at, in Desmos.com. So what you can do if you open your Google, what you're going to do is type in Desmos.com. Right? And as soon as you type in Desmos.com and you click search, you should see this website here, Desmos Beautiful Free Math. You click on that, and then it opens this page, right? So if you click on the top, there's a little math tools over here that you want to click. If you click on the arrow, it gives you the types of options and calculators that you might use. But in this case, what you're going to be using is the scientific calculator. And once again, it'll be back exactly where I was showing you guys before I went to Google. So what you can do is type in the numbers here. As for instance, in our slope, we had a numerator such that it said something like this: 10 minus 19, I believe. Let's see if Mr. Solis is correct. I believe that's what it was. Yes, 10 minus 19. So let's go back to the calculator. 10 minus 19, it'll give you your answer. 10 minus 19 is -9. So let's go back here, and we'll say, all right, this answer is, this simplified version is -9 over, and then we have -7 minus 20. So you would go back to the calculator and clear the screen, of course, clear it all, and you'll say, what was it? -7 minus 20. I think that's what the denominator had. And you get -27. Okay, so you would go back to your page or your piece of paper, and you would write -27. Now, hopefully by now, all of us know that a negative over a negative is just a positive number. So we get 9 over 27. And we do have to consider reducing or simplifying fractions. So if you're concerned about simplifying the fractions, do not stress about it. Just go to the calculator that I just showed you and type in the fraction, type in the ratio, type in the slope, and the calculator will reduce the fraction for you. And I'm going to show you that in a second. In a perfect world, though, 9 over 27 can be reduced to 1/3. Why 1/3? Well, the greatest common factor, between 9 and 27 is 9. So if you simplify this, 9 over 27 becomes 1/3. But like I said, or you don't understand what a greatest common factor is, it's okay. I don't want you guys to stress about this. Just go to the calculator that I just showed you. You're going to clear the screen, and you would type in your slope, your fraction, okay, your ratio. 9 over 27, I think that's what the slope was. And when you type it in, it gives you a decimal. Remember, we don't want our slope to be a decimal, okay? That's not going to help us. So what you want to do is click this button. It tells you convert to a fraction. Now here's the thing. As soon as I press this button, it's going to give us a fraction. if this decimal converts into the same fraction, that means that this fraction here, 9 over 27, is not reducible. But if when I press this button here, it gives us a different fraction, then that means that 9 over 27 is reducible. Okay, so let's check it out. Let's try it out. I'm going to click on this button. As you can see, whoop, the decimal turned into 1 over 3. So this fraction, 9 over 27, can be reduced to 1 over 3. Now, even though this is a different fraction and number-wise, they have the same value. 9 over 27 has the same value as 1 over 3. Okay, just keep that in mind. All right, so let's go back to our slides. Hopefully this was helpful. Remember, take advantage of this Desmos.com scientific calculator. It's pretty awesome. I recommend it. So in case you don't have an actual calculator. So let's go back to our slides here, and then we would say the slope, just to finish it off, the slope is 1/3. You can also describe it that the slope will be positive. The slope is positive since you have a positive number, a positive fraction, a positive ratio. And just keep in mind that it doesn't necessarily have to be a fraction. Your slope doesn't have to be a fraction, right? It can reduce to a whole number. Keep that in mind, okay? Because maybe some of you guys might be thinking, oh, if I get a whole number, I did something wrong. No. You can get a whole number when you reduce your fraction. It could reduce to a whole number. All right, so with that said, hopefully this example was helpful on how to find the slope given 2 points using the slope formula. And once again, here is the slope formula on the top. This is what you'll be using. Make sure you label your points precisely, and then everything else should, work out as long as you simplify it correctly. Okay. And in case somebody's asking what happened to the negatives, just a reminder, just a recall. A negative divided by a negative number is always positive. You can always go back and use the calculator, type in -9 over -27, and it will give you a positive fraction, 9 over 27. Okay. All right. So with that said, let's move on to the next slide. All right, guys. So in this case, what we want to do is find the slope of each line. So in this case, you're given this line, right? Everything's done for you, but you gotta find the slope. Now, you can use the slope formula if you really wanted to, but I would not recommend you to do all this work because you guys saw how much work we did, right? If you were given a graph with a line, there is no need to use the slope formula. It would be a lot easier just to use rise over run, right? Delta y over delta x, or the change in y over the change in x. So once again, you can use the slope formula if you want to, but in this case, I'm not going to use this method because that would take a lot more time. What I want you to practice now on this type of problem where the graph is given is use rise over run, which represents the slope. Okay, so here we go. We're going to say the following. M, which stands for the slope. Whoops, that does not look like an M. M, which stands for the slope, is equivalent to rise over run, which stands for the change in y over the change in x. And just keep in mind, I'm just gonna mention this. It's not part of the notes, but I guess a good way to see how rise over run works. The rise always moves up, or it could move down. That's what it does. Rise always moves up or down. That's it. It doesn't move any other direction. The number on the top of the fraction always moves up or down, depending. Now, how do you know if it moves up or down? Well, if the number on the numerator, on the top of the fraction, is positive, then it's going to go up. If the numerator, the number on the top of the fraction, is negative, then you would be moving down. Okay, that's a good way to remember. Over the run. Well, how do you know how the run works? Well, if the number on the denominator, on the bottom of the fraction, is positive, you will be moving to the right side. But if the number on the denominator, on the bottom of the fraction, is negative, then you will be moving to the left side. Okay? So that's pretty much how it works. All right, so here's the thing. Remember, well, if you don't remember, we mentioned in class that when the line falls from left to right, the slope is negative, right? If it falls from left to right, kind of like going down the hill, if you were, if you start on the left side, it starts going down, then it has a negative slope. But if the line rises from left, it starts rising, going up from left to right, then the slope is positive. That's something that I want you to keep in mind. So here's the thing. This is how you find the slope. I like to start on the left side, just the way I read a textbook or an article or a book itself. I like to start on the left side, so I'm going to call this point, since this is the first point I see on the left side, I'm going to call this point H for home, and I'm going to call this point S for school. Okay? Now here's the thing. I'm at my home, and I'm going to try to get to school, because I have to go to school, right? So what you want to do is start at your home, at your place, and try to get to your school. Right? But here we go. When you're starting to do the rise over run, always start off with the rise. You gotta start with the rise. Then you'll do the run. First the rise, then the run. Here we go. So if we're doing the rise, if I was to move down, am I gonna get closer to the school or further away to the school? And the answer to that would be, oh, well, Mr. Solis, you're going to get further and further away to the school if you move down, right? So I would not be moving down. I would be forced to move up, right? So many units. So you're going to count the grid lines. So if I want to get closer to the school, I got to move up. And I would go 1, 2, 3, 4, 5. So I'm going to count them. 1, 2, 3, 4, 5. That's 5 units, right? So I'm going to label it there. 5 units in red. That's for the rise. And you can call it rise if you want, or I also like to call it delta y. Delta y and then delta x. Delta y stands for, I should probably label it here. M is equal to delta y over delta x, which is the same thing as rise over run, or the change in y or the change in x, okay? Now, in addition to that, we want to find the difference or the distance between where you're at to the school. So in other words, you're going to take a run for it, right? You're going to take a run for it. You already went so many units up to get closer to the school. Now you're going to make a run across the street to get to the school. So how many units is that going to be? How many grid lines? 1, 2, 3, 4, 5, 6. So 6 grid lines, so that you're going to say that delta x, or the run, is 6 units, okay? So that's pretty much how it works. So then you would write your slope. Once you find the distance you're going to travel going up, the distance you're going to travel going to the right, then you would write the slope. Okay, so you would say m is equal to the rise. How many times did you went up? 5 different times. And since you went up, it's going to be a positive number over. You went to the right to get to the school. If you would move left, it wouldn't be a good thing because you would get further and further away from the school. So that would not be a good thing. So therefore, delta x, or the run, is 6. And as we can see, the slope is equal to 5 over 6. And 6 is a positive number since we are moving to the right side. Okay? All right, so there it is. That's how you find the slope when you're given a graph in 2 points. Okay? All right, so let's go ahead and move on to the next slide. All right, so in this case, we want to sketch the graph of each line. So in other words, you want to graph this equation, okay? There are 2 things that you need to identify first in order to graph this equation. 2 things. First thing is identify the slope, and second of all, identify the y-intercept. Just keep in mind that this equation is in slope-intercept form for us already, so it's ready to be graphed. So just a reminder, a slope-intercept form is just the format as y is equal to mx plus b. This is slope-intercept form, okay? Where the m represents the slope and the b represents the y-intercept. Okay? Intercept. Also known as the starting point. Also known as the initial value. Now, please focus on this. Once again, M is known as the slope. M stands for the slope. B stands for the y-intercept. This is the main keyword that we use, but in some textbooks, in some worksheets, some classes, some teachers will call it the starting points or the initial value, because in order to graph this equation, you literally have to start with your y-intercept. That's why it's known as a starting point, the initial value. This is what you want to start off with when you start graphing. So first of all, we need to identify the slope. And in this case, remember, the slope is always in front of the x, as you can see. In front of the x, you'll find the slope. In front of the x, you'll find the slope. So in this case, the slope is negative, and it's negative 1/2. Notice that the negative sign is right in the middle. I tend to write that negative sign on the numerator to make it easier for me when using rise over run. Okay, that's just a hint that you can do. You can always put the negative sign on the denominator if you want to, but I like to put the negative sign on the numerator, on the number on the top of the fraction, in other words. Okay, so my slope is negative 1/2 or negative 1/2, and the y-intercept, or b, is equal to negative 2. It doesn't mean that it's always going to be a plus number, right? A positive number. It could be a negative number. It could be a positive number. In this case, it's a negative number, so negative 2. Now that you identify your slope and your y-intercept, you are ready to graph this equation. So the first thing you got to do is place the y-intercept on the graph. That's the first thing you want to do. The y-intercept is always placed on the y-axis. So you identify the y-intercepts. This is your y-intercept right here. And you're going to place this number on the y-axis. The y-axis is just the line that goes up and down, up and down. So here we go. We need to identify the negative 2. And as you can see, the negative 2 is not on the top portion of the y-axis. It's actually on the bottom portion. So here we go. We're going to put a dot. There it is, right at the negative 2. There it is. Now comes in handy the slope. Now we're going to use the slope to create more points, to create our line, okay? So remember what I mentioned earlier about the rise over run. The rise always moves up or down, and the run moves right or left. So here we go then. So in this case, we want to start off with the rise. Since the top number is negative, that means that we have to go down. Remember what we mentioned. If the number on the top is negative, we move down. Rise. I'm going to write the word rise. Always moves up or down. The run always moves left or right. In this case, we're moving down for the rise because it's negative. 1 down and 2 to the right. So we're going to run twice. 1, 2 to the right side because 2 is a positive number. And we'll do it again. 1 down and 2 to the right. Okay. And I'll do it again. 1 down and 2 to the right. So as you can see, pretty much the pattern here was as follows. I'm going to rewrite this again. I guess I'll do it let me see if I can use, I'll use this color. I'll rewrite this over here. In our slope, m equals negative 1/2. I'm just going to rewrite this as a side note. The pattern was we're going down because the number is negative, over, we're running twice to the right because the number is positive. So now, if you wanted to create more points, notice how we ran out of space, right? We ran out of a graph, so we want to go backwards when we're trying to go the other way around, right? So instead of going down, we want to go up 1 now, over 2 to the left. If we want to go the other way around, so we would go up 1 and 2 to the left. And as you can see, these points will line up with the other ones. So 1 up, 2 to the side. And as you can see, it'll form a straight line. Okay, so there it is. Well, actually, I'll use this one to create a straight line. And even though I'm using a tool, it's not the straightest, but I'll try to fix it. Now it looks a lot better. Now it looks straight. There it is. Remember to put arrows on the ends because this is a line, and you do need arrows for a line, indicating that the line moves forever and ever in both directions. Okay, guys? So that's pretty much it. Hopefully, you enjoyed this video. Hopefully, this video was helpful. And if it was, don't forget to subscribe to the channel for more videos and smash the like button if you really enjoyed this video and found it helpful. And remember, we teach a new lesson like this one almost every single day. I'm Mr. Solis, and I'll see you on the next one.